Okay, sir. Good morning, sir. It's an opportunity for us to present the paper on this conference, sir. We have done a paper on composite material. The topic for this paper is contributing assessment of magnesium alloy composite augmented with boron carbide via liquid metallurgy. So myself, Alan Jeffrey, and our students are Anusha Roslin, Lazar Mary, and Santosh.
Abstract. Nowadays, low density composites plays a vital role of magnesium alloys, which gives high strength, better corrosion resistance, and meat castability. The additives used in my project is the boron carbide named as B4C, about 100 microns, with AZ91 magnesium for preparing a magnesium matrix composites through a strip casting route. A pit furnace setup is used for strip casting, and I take the volume of fractions B4C as 0% and 3% for doing the composites. I will increase the mechanical and metallurgical properties of the composites through micro hardness test and Vickers hardness through optical microscopy of the investigation.
Sir, to give an overview of what we have done is, we have chosen AZ91 magnesium metal, and first we have done with stir casting. So first what we did is, we just took readings with magnesium, that is 0%, and then we mixed boron carbide with it, and we found out the same test with the same readings, and we compared which one has a better ability or better standard in both the things. So the fraction which we chose was 0% and 3% of boron carbide for doing this composite. So all these things we did it in a lab. So here are the objectives of this work.
Objectives of our project: to do psychometric tests to detect the hardness of composite material, to gather the ultimate tensile strength to accurate the grain structure of the composite materials. Introduction of our project. In the bygone era of aluminum, the magnesium metal composites MMC is density is air density lower than the 30%. So we are trying to increase the density, and we are trying to increase the mechanical properties and the other chemical properties of the magnesium metals. We have some other magnesium properties, magnesium metals like AZ31B, AZ31, like AZ91. We also did semi-majors XRB and so many reference related to this. Our project results, we are using 3%. We are adding the components B4C 3% in our magnesium metal.
So this is just a pictorial view of magnesium alloy which we used for doing our work.
Magnesium alloy. To confirm the presence of magnesium in the test material, EDX test, EDOX test has been done, and the test report are attached. The same images of a XRD has been enclosed.
Here in this slide shows the presence of magnesium in the material, that is the material shown before. Here the magnesium, and the presence of magnesium is shown in figure 1, and the XRD of the thing, same image is also shown in figure 1. And this one is the B4C which we have used, and the chemical formula approximately is B4C. This one is an hard boron ceramic, and it's a covalent material used in tank armor and all those things. And this B4C has a density of 2.52 gram per centimeter cube, and its molar mass is 55.255 gram per molar, and the crystal structure and all those things is given. And the B4C is one of the hardest materials which we know, and the ranking third behind diamond and cubic boron nitride. So this adds strengthability to the magnesium, so that's why we chose B4C. So here is a same image of B4C, which is given in Newton meter, which is the presence of B4C in our thing. This is the same image, a photographic view of it. And this is the pit furnace that we used to cast our magnesium composite.
Stir casting. Stir casting is a process we used in our project. Stir casting is a liquid state method for the fabrications of composite material in which this dispersed phase is mixed with the molten matrix metal by means of mechanical stirrer. Stir casting process involves stirring of melt in which the metal is stirring continuously with the adding of boron carbide with material. We also attached the photography of stir casting. Metal matrix composites. In our project, we are doing metal matrix composites. The metal matrix composites is a complex materials which has been two minerals in which one metal is the bearing metal and the other is the reinforcement. The matrix is the rigid material in which the reinforcement such as ceramics are added. In this ceramics particles is B4C. MMC are made by this dissipate a reinforcing material into a metal matrix. The matrix is the monolithic material through this reinforcement is embedded and is completely continuous. But also it is used to change physical properties such as wear resistance, friction coefficient and thermal conductivity. That's much we are increasing physical property in our project.
Synthesis of magnesium metal matrix composites. Volume of magnesium AZ91 is cut into small pieces and measured through a weight scale, and then it met with the heat furnace of about 800 degrees Celsius. The furnace is preheated about nearly 200 degrees Celsius, and then it will fix with the heat furnace and through the in the RPM of 200, and the stirrer rod is used for mixing the melting composites.
Here, this is the outcome of the fabricated sample. Towards the right is the pure magnesium sample, and towards the left is the sample which has the presence of B4C. So we used, as we mentioned, we used a stir casting method in order to employ this material. This is a fabricated sample. And then these are the following literature review that we went through. So this is one paper where they are given the 3 casting on magnesium Ze442 alloy with removal of 2% carbon. Here we are using 3% carbon, boron carbide. Here it is given as 2%. And the next author was design and development with using stir casting technology suitable for processing magnesium alloy has been done in this study. Here, low cost stir casting process of magnesium alloy and its composite with flux and without flux has been explained. And the third one is about the AZ91D magnesium matrix hybrid composite with the boron carbide as well as graphite. Here they had 3 different samples, one sample with pure magnesium and another sample with B4C and another sample with graphite, and all these 3 have been thoroughly studied to find its hardness and ultimate tensile strength and all the things. And this one is about recent progress in vivo studies and clinical application of magnesium based biodegradable implants. Here also the magnesium is used with biodegradable implants, and it has been proved that these things have been used as biodegradable implants based magnesium. And this one here, the magnesium casting technology for structural application. Here they have used magnesium using different types of casting, for example die casting, sweet casting and loose form casting. And then this paper is viewed on the historical and current application and potential structure of magnesium. Here these are the general applications of magnesium which is used in automobile components and magnesium implants. And here it's for gearbox housing as well as for aeroplane applications. And here this is the exact methodology of how we carried out this work. First we chose the metal matrix composite, that is magnesium, and then magnesium is used in a stir casting liquid route where liquid metallurgy is used with plain magnesium and B4C. Both are casted. Then its mechanical and metallurgical characteristics are thoroughly studied and it's compared which has a better mechanical and metallurgical characteristics. And this one is, as you mentioned before, the photographic view of magnesium alloy. Here we just weigh different magnesium alloys for casting, and then the boron carbide is around 17 grams is used for stir casting process. And here this is preparation for the mold actually. So the magnesium is heated for the mold and then poured it into the magnesium alloy. And this one is the pit furnace that we use with the jar inside. That is this magnesium jar. With the magnesium jar is kept inside and the stir casting is used. And the stir casting will be explained.
So in stir casting process, mold is presented. We are put our equipments like magnesium and B4C into this mold and keep in this pit furnace for a certain temperature. After we could calculate the readings in side meters also, and this meter we had certain temperature to mold or cast our materials, and after the temperature reached, we kept away our byproducts like magnesium and B4C material combination, and we kept into a die and we cool down that room temperature. Then after cool down, it becomes a solid state of magnesium and B4C. Right?
Here the temperature adjustment and the readings have been noted down for different temperatures. Even the dye is being preheated to remove all the impurities from it, and then the dye is poured with magnesium. Here you could see all the process which is going, the casting is being removed out and then poured it into a mold to get a required shape. So these all shows the typical view of how we work with the magnesium and the B4C. And then after the molten metal is poured into the mold, it's allowed to solidify, and after solidification the mold is separated from the solidified metal, and we obtain the particular object. So now we are going into the, after obtaining the magnesium, we are going to the testing.
Test machines. We are used such as machines to test our materials. That's a micro-ordnance testing machine. Micro-ordnance testing machine is a method of determining a material ordnance or resistance to penetrate when test samples are very small or thin. Because test is often easier to use than other ordnance tests, since the required calculations are independent of the size of an interior, and the interior can be used for all materials irrespective of ordnance. The basic principles as with all common measure of ordnance. It is observed a metal ability to resist plastic deformations from a standard source. The Vickers test can be used for all metals, and as one of the widest scale among ordnance tests. The unit of ordnance given by this test known as the Vickers pyramid number HV or diamond pyramid ordnance DPH. Testing machines. We also tested other machines by our materials. Ultimate tensile strength testing machine. A universal testing machine UTM, also known as universal tester. Machines testing machine or material testing machines or materials test frame is used to test the tensile strength and compressive strength of material. An easier name for a tensile testing machine is a tensometer. Tensile strength testing is also known as tensile testing.
Here we could see the results of the micro hardness and the tensile test. Here you could see with the pure AZ91 and the AZ91 with the B4C, we could see in different locations. The micro hardness examination was done using a Wilson Walford Vickers hardness tester at 3 different locations, and indentation of 0.5 kg at 12 at 10 seconds. So you could see the results which is plotted over there in this table. And then this is the metallurgical assessment of the B4C and 3% B4C, that is 3% boron carbide. And here this is the ultimate tensile stress. We could see the ultimate tensile strength is found to be increased with 3% when B4C because of the carbide particles with the AZ91. So it is shown in graph A and B. 0% has around 150, and whereas with 3% B4C you could have around 150. The readings are recorded around 150. Here you could conclude that fabrication of AZ91 with 0% and 3% carbide was successfully made with shear casting. The samples of shear casting and sample were shown in the previous slides. Then the hardness of the composite material, it is increased up to 19.13% when it is when compared with plain AZ91. And then dispersion of B4C is also evident with reduced grain size and microstructure characterization. And then increased tensile stress is found in 3% B4C when compared to normal B4C. That is normal AZ91 as of B4C. So we have completed with the presentation. Thank you, sir. Sir, can we wind up or? Yeah. Yeah, sir.
We are also trying to evaluate its composite on AZ91 itself, but we have these casting for it. So one thing is that our work is that whenever we try to use the dispersion phase, a lot of the times we are not being able to
Yeah.
So have you found it? Because for us, most of the time, students get it kind of aggregate and one reason because this was homogeneous.
Yeah, sir.
This was homogeneous. Properties are not something that we.
Yeah.
So have you found it?
Yeah, sir. Actually, we do face the same issues. Actually, I myself am the guide for this project. Actually, we did two projects, one with B4C and one with SIC. So SICs we have to present the next paper. For B4C and SIC, for pure magnesium, it was absolutely right. Where using stir casting, we could have a lot of defects in the casting, and dispersion also was a little bit quite difficult in the earlier stages. So we had to work on sometimes 2 or 3 metals for us to get a exact one, because when the die is new and the pit furnace is new, we are able to get the exact dispersions. So that is why we just use stir casting method for a proper evident dissolving of B4C in the material. We too had the similar issues.
From what I can understand, So from what I can understand, diagnostic kind of this portion of the.
Yeah. It can. Yeah. Yeah. So actually, we are just new into this field, sir. Actually, because earlier we were working with biodiesels and automobiles, so we are just stepped into this structure, this project this year only. So we do have similar issues, but we didn't go with multiple squeeze casting, stir casting, all those casting. We just wanted to implement only stir casting alone.
Even actually, we are quite new.
Because a huge amount of money is involved, it is very difficult to do multiple works in this. Thank you, sir. Thank you.
Stop share.
Okay, sir. Thanks.